So hello and welcome back to the Computer Lab. So in today's video I'm going to show you how I made this network throughput tool. I'm going to go through the whole process. So how I fitted the mini OLED screen into this aluminium case. Also what software and how the software is installed within the Raspberry Pi, which is what's driving this unit, and also show you how this tool works by going to an IP address with the correct port number on. So what this allows you to do essentially is go into a customer's house and you can do some fault finding by connecting this unit up via the Ethernet cable and obviously putting the power on. It tells you the IP address. You then put the IP address in with a port number on a laptop that is Wi-Fi connected, and you can then test the throughput through the Wi-Fi device that may be on a network or something like that. So without any further ado, let's get into the video and let's show you how I started off. So to get started with what hardware I am using for this project, I'm using a SanDisk Extreme 32GB micro SD card. I'm also using a Raspberry Pi 4 computer, the Model B, with a 2GB of RAM. I'm using the official Raspberry Pi power supply, an Adafruit Pi OLED, which you'll see a bit later on with the description how to install that. And I'm also using a Flirc case, like you can see on the left here. The reason why I'm using this is because it's made of aluminium, so it's really good at dissipating the heat, and I can also cut around the processor of the Raspberry Pi to make sure that it still works. I will put links in the description box below for all these products, so you can, if you are following along with this project, you can just click on one of them. They will be an affiliate link, which basically means if you click on the link, you won't pay any more for that, but it means my channel gets a small kickback in the profit if you purchase any of these products through the links that will be in the description box below. Okay, so let's get to the putting some software onto the Pi. So the first thing we've got to do is install the Raspberry OS. Now I'm not going to spend any length of time showing you how to install the Raspberry Pi OS on the card. I would suggest if you don't know how to install Raspberry OS on the micro SD card is to follow the link, which I'll put at the top of the video now. Follow that link, that will show you how to install the Raspberry OS onto your micro SD card. But for the guys that do know how to install it and they're following this video from here at this point onwards, I am making sure that enabled SSH when I install the Raspberry OS, and I'm also installing the full fat version. I'm not installing the light version. You could do either or, to be honest, but I'm just installing the full fat version because I've got plenty of room on the card. It's a 32GB, and if I want to plug it into a screen later on, I've got the option to do so. Once we've got the Raspberry OS installed on our micro SD card, we can then pop the micro SD card into our Raspberry Pi like so. We then need to connect the Ethernet up and then connect the power up as well. Now at this point it's worth leaving it a couple of minutes just to obtain an IP address as soon as you get the power on. And you'll also notice that I am not connecting the OLED up yet. I'm going to do that later on once we've installed the correct script using terminal on the Mac. So I'm just going to leave it to one side for now. If you're doing this on a Windows 10 or Windows 11 machine, I would suggest using a program called PuTTY to SSH in and to install the scripts and there were different bits and pieces that we're going to do next. I'm using it on the Mac, so I'm using terminal on the Mac. Now my first instruction is going to be to ping the Raspberry Pi, so ping space raspberrypi.local and make sure it's got an IP address and make sure that it is on my network. And you can see that I've got a response back 192.168.0.102. So my next thing is to SSH into the Raspberry Pi. So the command to do that is SSH space pi at 192.168.0.102. And don't forget, yours will be a different IP address to mine. But once you've done that, it will then ask you to confirm you're happy with the fingerprint. Type in yes, and then type in the password for your Raspberry Pi OS. Click enter or return, and then you should be logged in, as you can see there in the green writing like I am. Don't forget, yours will be a different IP address, and also the Pi section of that, so the Pi at, is basically telling the Raspberry Pi that we want to log in via SSH with the user called Pi. Okay, the next bit is to upgrade and update. Now you can do these in single line commands. I'll put them in two separate ones, so I'm just pasting in off my document. And the first one is sudo apt-get update. Again, you can copy and paste these out of the description box below. The first one is asking Raspberry Pi to look for updates, and then the second command that we need to do is the upgrade one. So we then need to tell Raspberry Pi to go away and upgrade everything, which is sudo apt-get space upgrade space -y. So again, this is one of them processes that can take a while. It can take anything from 10-15 minutes and longer, depending on the speed of your network and internet and stuff like that. So I would suggest go away and make yourself a cup of tea, a cup of coffee, and then wait for it to finish. And once this is finished, I'm then going to install Docker. However, I'm just going to clear the screen so we've got a bit of a clearer view of what's going on. So let's clear that off. That's all the previous history, just clear it, and we're back at the top. Now I've included this part of the video even though this part didn't seem to work for me. So the next bit is to install Docker, as you can see. So the command is what you see on the screen. Again, it'll be in the description box below. However, for some reason, I could not get this to execute. So obviously you can see the command there, the curl space -ssl space https, the get-docker.sh. But then when I got to my prompt and then typed ls to list, I would expected to see Docker in there, but it wasn't present. Now I'm not fully au fait with the Raspberry Pi and this language, so I tried to run it anyway. So I did sh space get-docker.sh. And then obviously it can't open it because it can't see it. Now I'm hoping the Raspberry Pi people that look and watch this video will comment below and tell me why, or if it didn't work, or what I did wrong at this point. But I had to go for a different command. So clear the screen, and then went for the command that you will see now on the screen, which is I think it's beginning with the fssl command. So curl again, it's got fssl in it, and it's also got the -0 near the end. It didn't seem to do anything, but then when I did a list at this point, it then listed the get docker in there. So at first I was going to just go straight for it and type ssh get-docker like I did earlier, but I thought, no, I'll try the list command. Sure enough, it is there, and then I know I can now run it. So then I typed in sh space get-docker.sh. And then this, as you can see on the screen, it says it's already possibly installed, but even though it wasn't listing it, and I can cancel if I want, but if I want to upgrade it or update it, then I can ignore this message. So I just ignored it and let it go away and do its thing. So I'm presuming it was installed, but I wasn't listing it correctly. I'm not sure what went on there, but like I say, hopefully somebody will watch this and give me a description of what went on and what I did wrong or what I did right on the Raspberry Pi commands. And the last thing we need to do before we reboot is just add the Pi user to the Docker environment. So that is a command in itself, and then once we've done that, we then need to reboot the Raspberry Pi, so it then refreshes the user list. So the command for this is sudo space usermod space -ag space docker space pi, and all that does is add the Pi user to the Docker environment. And at this point I can then do a reboot, and so sudo space reboot, and that will log me out of the Raspberry Pi and reboot, so I can then log back in. And again, if you're new to Raspberry Pis and this type of environment when you're logging in via SSH, you can either wait a couple of minutes to wait for it to reboot, so you know that it's actually started up again and been given an IP address with your DHCP on your network, or you can send out a ping and then wait for that ping to respond back. So I'm just pinging it 192.168.0.102. And once I get a response back from the Raspberry Pi, I can then quit the ping that I've sent out, clear the screen, and then I can use the login details that I set up when I set up my Raspberry Pi OS. So again, I'm just typing in the command ssh space pi at IP address, push enter return, put the password in for the Raspberry OS, and then now I am logged in as my Pi user on my Raspberry Pi again. Now at this stage, it's always good to test to see if Docker is working okay. I've done a couple of these now and I've always tested it. However, especially with this one, I had an issue installing Docker, or I thought I had an issue, so it's almost certainly worth me testing Docker to see if it's working okay. So I typed in Docker first, and then I typed in docker space run space hello-world. And you can see on the screen, it'll give me a message in a second to say that it is working. So hello from Docker. This message shows that your installation appears to be working correctly. So that was great. I knew then that Docker was working okay. So now there's a couple of final commands, I think 3 or 4 commands that we need to enter, and these get longer now, so I'm not going to read them out or explain what they do. Just copy them out of the description box below if you are following along. So the first one is there, I've entered, and it's to do with Docker. The second one is the portainer, which sits in Docker on your Raspberry Pi. All you're seeing there is it going away to the Portainer website and downloading it onto your Raspberry Pi. I'm going to clear the screen, so I'm going to clear run. Next one is obviously longer than all the others, and enter that one. And the last but not least command is the one that installs openspeedtest within Docker and Portainer. So obviously copy and paste again, hit return, enter on the keyboard, and let it go and do its thing. I have speeded this bit up, but it doesn't take it long to do this part of the process. And once it's done that, we can then log into Portainer via the IP address. So I'm not rebooting, I'm just leaving the Raspberry Pi switched on and on my network. I'm going to go to my IP address, which is 192.168.0.102 : and then port 9000. And then this takes us to Portainer, and all Portainer is an environment for managing your Docker in. So it's going to ask for a password. I'm just going to stick my just a general password in there for now. Click create user. Notice I'm on admin as the username. Click create user. Obviously that's Mac asking me what to save it. And then click on Docker, and then click connect. So that's great. We now know that we can log into Portainer. We know it's up and running and working. And then I can click on my local environment here, click on containers, and you'll see what exactly has been going on. You can see my hello world, which I ran earlier within Docker. You can see Portainer, and you can also see openspeedtest. And the important bit here is the published ports. So obviously 9000 is the one that we've just been using for Portainer on the back end of our Raspberry Pi IP address. So now I just need to go to 192.168.0.102 : and then the port number 3000 to open my speed test up. And there we go, straight away we're in speed test. So I'm connected wirelessly at the moment to through this speed test, and you can see the speeds that I'm getting through my Wi-Fi connection. Now the point being here for the Raspberry Pi, which is 192.168.0.102, if you're going into a client's environment and you plug your Raspberry Pi in, that IP address will change, and that is where the small OLED screen that I installed is going to come into play, because when you plug it into a new environment, I want to see what IP address it is going to be given, and then I can go to that within a browser on a laptop, and then just put the port number in on the back of it, and then that will take me straight to my speed test tool. So that's the only reason that the OLED screen has been installed on the Raspberry Pi, which is what I'm going to show you next. So the screen that I chose was a small Pi OLED from a company called Adafruit. It's got a resolution of 128 by 32, and on the Adafruit website there's some really good tutorials on there on how to install these small Pi OLED screens onto your Raspberry Pi. So I just simply followed along to the tutorial that is on their website. The first instruction, as you can see, was that sudo apt-get install python3-pip. It says, do you want to continue? You click yes, push enter or return. It goes away and finishes that. The next one, I think, was an upgrade command. I don't know if that's updating the Python 3. No doubt somebody will correct me if that is incorrect in the description box below. But you can see the instruction, sudo pip3 install upgrade setup tools. So it goes away and does the upgrade or update, I'm presuming, of Python 3. And the next command is a multi-line command, so you just paste it all in one go. You do have to push enter on a couple of times when it pauses and stops. And it also asks you, do you want to continue halfway through this process, which you click yes to continue. So again, it's paused there, push enter, it will carry on. Then asks you, do you want to confirm? Click yes, continue, to push Y and then enter. It then carries on updating Blinker or installing Blinker onto your system. Once it's done this, it then asks you to reboot. So again, Y, yes, and then we'll have to log back into the Raspberry Pi. So at this point, I think I'll clear the screen just to get us a fresh start so we can see what we're doing. So just type in clear at the command prompt, and then that will get you back to a clear screen to work from, so you're not looking at the full list. So again, log back in, SSH Pi at your IP address, mine's 192.168.0.102, the password for the Raspberry Pi OS, and then we're now ready for our next command. So the next command is this ls command, which basically checks that the I2C is working, which is how the Raspberry Pi communicates with the Pi OLED. So as long as you see that, what you see in the middle of the screen there, after you've inputted that ls-dev command, then you know that your screen is working. And for some reason, it asks you to reboot again in the instructions on the Adafruit website. So I'm going to do a full shutdown again. At this point, you see the sudo shutdown -h-now. And all that does is shut the Raspberry Pi down. I don't know why it asks you to restart after it has just restarted, but I was just following along to the Adafruit instructions at this point. So again, now I've rebooted and waiting for it to come back up. So I'm just waiting for my Raspberry Pi to start. Log back in again with the same Raspberry Pi OS login details again. And now I can do my next command, which it tells you to input this sudo I2C detect. And as long as you get that same one there with the free C that you see in the column C, then you know it's working. The next command in the instructions is the sudo pip3 install Adafruit circuit python SSD 1306. So input that one, let it go away and do its thing. And then there is another apt-get install python3.pil instruction. And I think at this point, once it had finished installing them, I think I clear the screen now, because the next instruction is to save some code that is directly from the Adafruit website into this file. So this instruction is this nano pi-stats.py. That will take you to the file where you can save the code, like I said, which is pasted directly from the Adafruit site. Once you've pasted it in, you can then exit in the bottom left-hand corner. It tells you all the instructions along the bottom line, as you can see. So you paste the code in directly from the site, and then simply use the command that you can see on the bottom there to exit from this point. Then it will ask you to confirm by typing Y for yes, and then it will ask to confirm the right file to the actual folder, so file name to write, push enter on the keyboard, and it will take you back to the command prompt. And at this point, we've just got one more line of code to input. So this one is to start this same program every time we restart the Raspberry Pi. So it's sudo nano rc local, and we're just going to edit one line in this particular file. Again, it's copy and pasted from the Adafruit website. Use your cursor keys to scroll down, and then just put it before the exit 0 command. And like I said, this command here just tells the IP address and stuff like that to show up on the screen every time we restart the Raspberry Pi. So it's that sudo python3 home pi stats.py, and that's just asking for that program to run every time we restart. Obviously save that on exit in the same way, so close that file down, and then we're back to the command prompt, and then we can now finally get to testing the screen. So I'm just going to put my screen, plug it in. This is the first time it's going to be tested. So this was a sort of a live test as I'd finished programming. So you have to wait a minute or so for the Raspberry Pi to boot up. So don't be thinking it's not working, because I think it takes it probably about 2 minutes maybe to boot in. Then obviously start everything up and then run the Raspberry Pi. The first IP address it gives is not the one from your network, so that 172. From what I found is sort of the one that gets listed either in Portainer or Docker, I can't remember. Once it's picked up from your network, it will then refresh. So you can see there I've got this 192.168.0.102. We've also got some CPU and memory stuff on there. So that is it. We know now that finally the Pi OLED is working and giving us the information we need. So finally getting to the final stages, I then cut into the aluminium case using a Dremel tool. I used multiple different bits just to recess, and probably took about half an hour to cut it out. I wasn't too bothered about being really tidy here, but obviously I wanted it nice and clean so it wasn't going to catch anything. But my point here was to relieve it so the OLED would fit into the case whilst still leaving the sort of protrusion that comes out of the back, which connects to the CPU on the Raspberry Pi. So obviously relief for the OLED, but then this section here I wanted to make sure that was left whole, because later on I might want to overclock my Raspberry Pi, and the whole case acts as a heatsink for the CPU once it sits on. So at this point it was time to do a dry run once I'd known that I'd relieved and made sure this was happy with that. I did have to tweak it a couple of times and come back to it, so a few times I did try it in. The case obviously covers the top of the aluminium case, so it's not too bad if you just scratch it a bit there with the Dremel tool. It's not, in the end of it, this is going to be a tool I take to site, so it's not going to have to look too fancy. So again, like I said, I did a dry run here, popped it all in, and then made sure the card was in, make sure everything was in position, and then plugged it into Ethernet, plugged it in the power, and then made sure that it worked and booted up as I expected it to do. Once I was happy with that, I then put the thermal pad onto the Flirc case where the CPU sits, and then obviously I knew it would fit because I've already done the dry run. Then popped it all in, make sure it's seated correctly. I mean, if you really wanted to there, you could maybe put some glue or some double-sided tape on the Pi OLED, the screen. I didn't want to do so, just obviously rebuild it up. And then pop the 4 screws in the back, and then finally the micro SD card. And then the final thing to do was to cut out the black plastic cowling. I made myself a little cardboard template and cut out where the screen was going to sit. Made sure it was all nice and flush. And then drew on top of my black plastic cover with a marker pen, and then cut round this using a Stanley knife. Now, I might have been better using a Dremel. The only reason I didn't use a Dremel because I didn't know if it would melt the plastic or not. So I started doing the Stanley knife, but the plastic is really hard. It took a while, and to be honest, it could have been a tidier job, could have been a cleaner job than using the knife that I did. But like I said earlier, it's going to site. As long as I can see the IP address, I wasn't overly fussed, as long as it wasn't too messy. But with hindsight, I maybe will use a different method to relieve that section out there. But as they say, you live and learn. So just click the black plastic cowling, cover on top, and there we have our network test device. Now, the one last thing that I wanted to really ask the community or anybody who watches this video, and put it down in the description box below, is when I do a speed test on the Raspberry Pi, the maximum speed I can get on Ethernet connected to Ethernet connected device on the network is 700 download, whereas the upload is what you'd expect, around the 960-70 mark. So that's obviously nearer to the 1 GB connection we expect to see. I don't know why the download only shows 700, but for my purpose in testing access points, it is more than fast enough. I know that the Raspberry Pi is running quick enough for that. However, if I'm wanting to test locally on a local network, I don't know why the download is only reaching 700. If it was the micro SD card, I would have expected the upload to be the same. So I'm not 100% sure if it's limitations of the Raspberry Pi, if I need to overclock the Raspberry Pi in some way to make that quicker. I'm not sure. Please do let me know in the comments below. And if you've got this far in watching this video, thank you very much for watching my tutorial on creating a Raspberry Pi speed test network tool. It really is appreciated. And if this video has been helpful, please hit the thumbs up. Please do hit the bell icon to be alerted to any new videos I make, and also hit me with any comments below. They are really appreciated. And thanks again for watching The Computer Lab on YouTube.